Have you ever stopped and wondered what's really going on inside a tool like ChatGPT? I mean, how do you actually go from the entire messy, chaotic internet to a helpful AI assistant that can write you a poem? Well, let's dive into this, because today we're breaking down the two-part recipe for building an artificial mind.
It's really the question on everyone's mind, right? For most of us, this whole process is a complete black box. But what if I told you that the entire, incredibly complex operation boils down to a surprisingly simple two-part recipe? Yep, that's it. The recipe has just two main parts. First, there's a learning phase, where the model essentially swallows a library the size of the internet. And second, there's a tuning phase, where it learns how to actually be a helpful assistant. That's the whole idea. Learn first, then tune.
Okay, let's start with phase one, learning. In the industry, this is called pre-training, and you can think of it as the model's general education. This is where it just sits and reads and reads and reads, learning facts, language, culture, and all the basic patterns of how we communicate.
But you can't just feed it the raw internet. It is way too messy. So the first step is this giant data funnel. They start by sucking in about a petabyte of data. Then comes the really hard part, filtering. You got to get rid of all the undesirable content, the duplicate pages, and just the low-quality junk. Finally, that data is curated, which means high-quality sources like code, books, and Wikipedia are given more weight.
So what is the model actually doing with all this beautifully curated data? Well, it's doing something called language modeling. And this is where the core idea is almost shockingly simple. The model looks at a sentence and just tries to predict the very next word. That's it. It just does this over and over again, billions and billions of times.
And when I say billions, I'm kind of underselling it. A cutting-edge model like Meta's Llama 3 is trained on about 15 trillion tokens. Think of tokens as pieces of words. The scale is just, it's almost impossible to wrap your head around, and it's absolutely key to how these things work. Now here's where things get a little weird and counterintuitive. See, in traditional machine learning, you're always worried about overfitting, where the model just memorizes the data instead of learning from it. But with these huge language models, the rules seem to be different. It's a phenomenon called scaling laws. Basically, the bigger the model and the more data you throw at it, the better it gets. Overfitting just doesn't seem to happen. It's a total game changer.
So at this point, we have this brilliant model that knows so much, but it has a major weakness. If you ask it to explain the moon landing to a 6-year-old, it doesn't know how to follow that instruction. It just sees a pattern, and it might complete it with something similar, like explain the theory of gravity to a 6-year-old. It's a genius librarian who knows where everything is, but it's not a helpful assistant, yet.
And that limitation is the perfect bridge to our second phase. We have our brilliant librarian, but what we want is a helpful assistant. So now the AI needs job training. This is where that incredibly knowledgeable model learns the specific skills of being useful, helpful, and safe.
So here's the difference, in a nutshell. The pre-trained model, it knows facts, and it's great at completing text patterns. The post-trained model, it keeps all that knowledge, but now it learns to actually follow instructions and be helpful. We're literally transforming it from a text predictor into a real conversational tool.
The first step in this job training is something called Supervised Fine-Tuning, or SFT for short. Here, real humans write a small but super high-quality set of perfect questions and answers. The model is then trained on just these examples. Now, the key thing to get is that it's not learning new facts here. It's learning the style and the format of a great answer.
But you know, writing thousands of perfect answers is incredibly slow and really expensive. So the new, smarter way to do it is to learn from preference. It turns out it's much, much easier for a person to look at two answers and say, that one's better, than it is to write a perfect answer from scratch.
The way this works is basically like a huge series of A/B tests for the AI. For any given instruction, the model generates two different responses, A and B. A human labeler then just picks the one they like more. You do this thousands and thousands of times, and the model starts to learn what humans actually think a good answer looks like.
And the result of all this tuning, the payoff? Well now, when we go back and ask our model to explain the moon landing to a 6-year-old, it actually does it. It totally understands the instruction, it adopts the right tone, and it gives a direct, helpful answer. The job training worked.
So, we've seen the whole two-part recipe. Learning, then tuning. But when these big AI labs are building these massive models, where do they really focus their time and energy? Well, the secret sauce isn't what you might think. While people on the outside love to talk about fancy new model architectures, in practice, that's actually one of the least important parts. What truly matters, where the real work happens, is in the massive effort of data curation, in building really solid ways to evaluate if the model is getting better, and in the raw systems engineering to make these huge computations even possible.
And that just brings us right back to the incredible importance of scale. Building a single, top-tier model like Llama 3 costs somewhere in the neighborhood of $75 million. I mean, think about that. That immense cost shows you why making those systems efficient and making every single piece of data count is so incredibly critical.
So at the end of the day, the takeaway is pretty clear. Right now, progress in AI is basically driven by scaling up data and compute. Bigger is better. Which leaves us with a final, really fascinating question to think about. If the recipe for better AI is just more and more data, what happens when we've read the entire internet?